All right, so we have an electron traveling with a speed of 2.5 times 10 to the 6 meters per second, collides with a photon having a frequency of 1 times 10 to the 16 hertz. After the collision, the photon has 3.18 times 10 to the minus 18 joules of energy. Calculate the original kinetic energy of the electron. So that means before the collision, so I see the electron has a speed of 2.5 times 10 to the 6 meters per second. So what do we do for kinetic energy? We look in our reference table. The equation for kinetic energy, KE equals 1/2 mv squared. Right? So first, we need the mass of an electron, which you can find on your reference table. So it's 1/2 times mass of electron, which is 9.11 times 10 to the minus 31 kilograms. All right, we multiply that by the speed, 2.5 times 10 to the 6 meters per second. And that quantity squared. We plug that in our calculator and we get 2.85 times 10 to the minus 18 joules. All right, determine the energy in joules of the photon before the collision. All right, so before the collision, we see we have a frequency of 1 times 10 to the 16 hertz. We also see after the collision there's this energy in joules, but that's after the collision. We're looking for before collision, okay? So what's our equation that gives us energy of a photon with frequency? We look in the modern physics section of our reference table and we see E photon equals HF. So we have E photon equals HF. Where H is on our reference table. H is Planck's constant, and H is 6.63 times 10 to the minus 34 joule seconds. And we multiply by the frequency 1 times 10 to the 16 hertz. And we get 6.63 times 10 to the negative 18 joules. All right, now for 84, determine the energy lost by the photon during the collision. Okay, so we're just looking at the energy before. We see the energy before, we have this 6.63 times 10 to the minus 18 joules. And the energy after is less, 3.18 times 10 to the minus 18 joules. And all we're going to do here is subtract that. If you got a different answer, if you got number 83 wrong, you would still just subtract your answer for 83, subtract the 3.18 times 10 to the minus 18 joules, and you would still get full credit for this one. So all we're going to do is subtract them. 6.63 times 10 to the minus 18 joules minus 3.18 times 10 to the minus 18 joules. We get 3.45 times 10 to the minus 18 joules. All right, number 85, name 2 physical quantities conserved in the collision. And you can just name quantities that we know are conserved in any collision. So we can name our 2 favorite conservation laws, or conservation of momentum and conservation of energy. These are both conserved. If you want even more, you can say mass or charge is also conserved.